Hi guys, so this video is gonna help you get through this GSRTB4 worksheet, reviewing, proving theorems about triangles so that you can be super successful on that quiz to bring up your grade. All right, so let's get started. Number one, these problems we are looking to use similarity facts to find the missing lengths. So not Pythagorean theorem, we're not going to assume that any of these are right triangles. And we're going to solve for the missing length, preferably using scale factor. So number one, here's my question mark. Here's what I'm looking for. I'm looking for the side length of DE. Now, they didn't give me a similarity statement, and these triangles are embedded, so we're allowed to assume that DV is going to correspond to DF, and DU is corresponding to DE, okay? Something else that I noticed is that triangle DVU is an isosceles triangle because these side lengths here are exactly the same, which means that my bigger triangle DFE should also be an isosceles, and that 104 here is the same as 104 there. So we could already say that DE is equal to 104. Maybe you didn't know that, or maybe that wasn't the case. We're going to have to look for our scale factor, which means taking the things that I know are similar, that are corresponding, and setting them equal. So we can solve it by looking at, I know 16 times some number calling scale factor is equal to 104. To solve for that scale factor, I divide by 16 to get 6.5. Now I would take my scale factor and multiply it by du. So du times my scale factor would equal to dE. So looking at it with our numbers, 16 times 6.5 would give me the measurement of dE, which is 104. Okay, moving on, you should be able to do number 2. Number 4 is sort of similar to that number 1 in the sense that they're embedded triangles, so make sure that you're just matching up the corresponding sides. Looking at number 3, we have a similarity statement, which means I need to make sure that I'm going in order. So NM corresponding to NB, meaning they're proportional, not equal. ML corresponds to BC. And then lastly, L back to N corresponds N to C. Okay. So here I need to set up a proportion. I can't just set them equal each other, because if you set them equal to each other, then you're saying that they're the exact same length, but they're not. They're proportional. These triangles are similar, not congruent. So I can say that 3x minus 3 over 63 is equal to 14 over 98. So what I did here was across my tops, I have the same triangle. Well, across tops and bottoms, these are both from the same triangle. And separate fractions itself, like this, these are the corresponding sides. So remembering that those things have to match up either by fraction or by row. From this step, we're going to do cross multiplication. So I'm going to have my 98 being multiplied by 3x minus 3, and that equals to 14 times 63. Doesn't matter which order you write these numbers, I kind of just put them there and use parentheses, especially for this 3x minus 3 part, so that I remember to distribute my 98 to the entire problem. So I've got 98 times 3, and that's going to be equal to 294x minus 294 equals 14 times 63 is equal to 882. Now we just go ahead and solve for x by adding my 294 to get 294x equals 1176, and divide by 294, x would equal 4. How next, right? Okay, moving on. Now we have solving for angle degrees. So we're going to have to use our knowledge about isosceles triangles, equilateral triangles, our external angle theorem, or exterior angle theorem, sorry, and knowing that all angles in a triangle add up to 180 degrees. I kind of forgot to mention that. And also your supplementary angles, complementary angles, right? You know what complementary angles add up to 90 degrees, supplementary angles add up to 180 on a straight line. So let's start with number 5. My unknown is right here next to my 72. And unfortunately, they're not on a straight line like this. Like if it were like that, I know that's not very straight either. But if this was 72 and this part was x, then I know I have supplementary angles and I just take 180 and subtract 72. Unfortunately, that's not the case. So what we have is noticing that I'm going to say, here's my green triangle, the top one. Okay. That's isosceles. It's isosceles because of these two markings here saying that they're equal sides, and also the opposite or the angles across from them are going to be equal. So that one in the corner is 72. This one is also 72. Okay. Now I can solve for the rest of my triangle because my last angle will just be whatever's left over from 180. So I'm going to take 180 minus 72 and subtract 72 again to get the fact that this is 36 degrees. Okay. I was also told in this diagram that this is a right angle, meaning I've got a supplementary or complementary angle there with the 36. So I'll just take 90 minus 36. And the one below it right there, this is 54 degrees. Okay. Now I'm going to highlight this bottom triangle, call it my purple triangle. And this one is also an isosceles triangle because of this marking here and this marking here, saying that they are equal, the same, and that the opposite angles from those sides that are the same have to be equal. So this one is also 54 degrees. Now all that's left to do is solve for x. And that is 180 minus one of my 54 degrees, and then minus my other 54 degrees on the other side. And it's actually 72 degrees. How interesting how that came out to be the exact same thing. So that's how you're going to go about this one and this one. It's going to be quite a stretch to get through, but I know you guys can do it. Let's look at one more because these are kind of your exterior angles. So number 7, let's see. Number 7, 115 lies on a straight line, which means we've got supplementary angles, and this must be 65 degrees because that is 180 minus 115, 65. And also, this triangle is an isosceles again because we've got same side there, so 65 should also be here. Okay, solving for the last angle of my triangle because I know all angles in a triangle add up to 180. I'm going to take 180 and take away my two 65s, and that's going to equal to 50. Now I've got a vertical angle here to my 50. So that means this one is also 50. Now I have another triangle here that is also an isosceles triangle because of these markings. If this one is 50, this one is also 50. Okay. Now we could go ahead and take 2 more steps to solve for my last angle of my triangle here, and then this angle here by using supplementary angles. But we did talk about the exterior angle theorem. Okay, exterior angle theorem says that this angle out here should equal to the 2 opposite angles on the inside of the triangle added together. So x should equal to 100 degrees. Okay, and let's check. So if I wanted to find this final angle right here, I'm going to take my 180 and minus my 250s, which is 100, and that is 80 degrees. Okay, if that's 80 degrees and this angle along with x lies on a straight line, that means they're supplementary, and I would take 180 minus my 80 to solve for my x, which is 100. So we just solved for x, and you're going to do something very similar for number 8, and you are done. Okay, once you've finished this worksheet and you've submitted it, I can give you some feedback, and then hopefully you'll be super ready for that quiz to make up your grade. Good luck, and email me if you have any other questions.